So once again, good morning and welcome to this latest webinar from Flex Power Modules. Today's session will discuss the pros and cons of modules versus discretes, basically, or the build versus buy dilemma, which is a common dilemma that many engineers and many people have during the evaluation phase of different solutions for their DC-DC solutions. The presentation will be hosted by Bob Cantrell, who is our senior field application engineer. Bob is actually located in the US, and just for you to know, we have pre-recorded his session, and good job that we have, because Bob's actually unfortunately unavailable for us today. My name is Phil Goff, and I'm product marketing manager, and I'll be the moderator of the call today. And the agenda for the session will basically look like this. So I'll just give you a brief introduction to Flex Power Modules. Then we'll go on to the discussion hosted by Bob on the pros and cons. And as I mentioned at the end of the call, we'll have a Q&A session where you'll be able to put your questions to Oscar Persson, who is one of our senior R&D engineers in our Kalmar facility in Sweden. So even though Bob's unavailable to join, we have an excellent stand-in with Oscar to join for the Q&A session later today. So with that, I will look at giving you a brief introduction. For those of you that maybe are not aware, Flex Power Modules has actually been around for sort of more than 40 years now. Previously, we were Ericsson Power Modules. And this year will mark, I think in October, our 5th anniversary of being acquired by Flex. So even though the sort of name is maybe new in the industry under Flex Power Modules, we have a whole remit of history in both the telecom and datacom or ICT sections of the markets. But also more recently, we have introduced a wide range of products for both the industrial segment and the transportation segment as well. We do feel we are a technology leader in the DC-DC power. It's what we've focused on from day one, basically, and we continue to focus on DC-DC. Many customers will ask, if we do AC-DC solutions, and as Flex Power Modules, we purely focus on the DC-DC side of the board. And as I mentioned, we have a very wide product portfolio, so we're able to offer a very good system solution from the very lowest requirements up to the very highest. We very much do focus, I would say, on bringing high technology developments to the marketplace. So products now putting out more than 2.5 kilowatts in a quarter brick, for example, is one example of one of the latest products that we've introduced. And a big focus for us has been on digital solutions as well. So when it comes to digital DC-DC converters, we really are, a leader in that field, and that's an area that we are known for. We are also working together with our key customers in terms of developing tailor-made solutions. So bear that in mind in the future as well. Should there be specific requirements that you have for very dedicated power modules, then we do have those capabilities. And our strap line, if you will, is that we power our customers' innovations. So with that, I'm going to hand over to the pre-recorded session with Bob. And once that is finished, we'll come back live and I'll be joined by Oscar Persson, and we'll be able to pick up any questions that you might have had during the presentation. So over to Bob.
Thank you very much, Phil, and hello, everyone. So, the pros and cons of building versus buying as it relates to power solutions. This discussion has been going on for many, many years, but we at Flex Power Modules would like to give our perspective on how modules and discrete solutions stack up against one another, especially when considering the total cost of ownership of a voltage rail. When we look at an iceberg, the portion above the water is usually the only part that we think about. Unless we were to put on scuba gear and dive into the frigid water, we really have no idea how deep the iceberg actually goes. This analogy often applies when comparing the cost of a building discrete power rail as opposed to using a power module. The point that usually comes to mind first and often carries most of the weight in the decision-making process is the bill of material or the BOM cost. Just as when we view an iceberg, the cost that we can most easily see is usually what we focus on. And not surprisingly, the discrete solution wins the first category. But we should keep in mind that BOM costs include only the material cost of the solution itself. As we will see, the discrete BOM cost is only one component of the total cost of ownership, or the TCO. Next, let's consider component layout flexibility. Discrete solutions are flexible and can be customized to specific physical requirements. It is sometimes possible to lay out discrete components where there's not enough room to put a modular solution, such as on a round PCB, for instance. On the other hand, a module is limited to a specific aspect ratio, which can make it less flexible in layout options. However, when there is available height, one type of module, the vertically mounted SIP module, can be used to regain some of that flexibility, sometimes even offering more flexibility than discrete solutions due to a SIP's inherent minimal board area. Ease of design. For this category, we're going to consider what kind of competence and skills are required when designing in and laying out a power rail. Whether doing an in-house custom design or using a reference design, a discrete solution requires some varying amount of power design expertise. On the other hand, a modular solution is easy to implement for non-power experts with a little FAE support and software support, such as the Flex Power Designer. The next category we'll discuss is the required board area. The discrete solution board space is a function of the number of components and the motherboard design rules for required component separation, and it is typically laid out on a single layer. Now, let's consider the required board area for power modules. Power modules typically save 50% or more motherboard area due to the ability to put components on both sides of the PCB, and in some cases, even the Z-axis. Motherboards often have 20, 30, or even more voltage rails, so the surface area saved for one rail is further multiplied, resulting in a substantial motherboard real estate savings. For applications with available height, SIP packages can be used to further free up additional motherboard space. Number of parts needed. For this topic, we're going to compare the total number of parts on a bill of material for discrete versus modular solutions. First, let's look at discrete solutions. They obviously have a lot of parts. Modules, on the other hand, have very few components. There's only one module for up to 2 voltage rails, plus a few filtering components. And this has several advantages. Vendor and part number proliferation are dramatically reduced, which leads to easier management and control of inventory. There's also reduced labor and overhead relative to picking and placing a module versus individual discrete components due to the reduced part count in manufacturing. Now let's consider safety approvals. In the case of discrete solutions, the approvals are the customer's responsibility. Now, on the other hand, power modules bring to the table a full suite of safety approvals along with extensive qualification testing. For instance, type testing and approvals can take several months to perform. Here are some of the approvals that are done by module suppliers based on the type of application. For example, Datacom and Telecom power modules meet IEC EN UL 623868-1, while railway products comply with EN 50155. And of course, the most power module manufacturers are ISO 9001, 14001 certified. The next topic is scalability. Let's look at how the products scale. When using discrete solutions, new designs are typically needed each time design changes occur. But this is not the case with module solutions. For example, let's assume that after actual silicon finally arrives, its power is dramatically higher than anticipated. How can this increased load be accounted for? There are industry standard power module footprints, which makes it easy to increase power within a given package size. For instance, quarter bricks range in power from just a few hundred watts up to 1,500 watts or more. Also, the flexibility and programmability of today's digital products means upgrades are greatly simplified. Modules can be used in series or parallel configurations, further increasing the potential number of design alternatives. And product variants are often possible for specific customer requirements. Now let's compare the verification of electrical performance. With discrete solutions, the performance of the collection of components in its bill of material, once assembled on the motherboard, needs to be tested and verified. In contrast, the power module provides a complete power solution that's been pre-tested using a defined, proven, and documented set of electrical parameters. Also, with modular solutions, EMC characteristics are well defined and typically suitable filter suggestions for meeting Class A or Class B conducted EMI requirements are provided for ease of design. Now, let's take a look at the typical thermal performance between discretes and modules. With discrete solutions, power and signals use the same host PCB, so it is more difficult to optimize thermals. However, with modules, this is not the case. Modules are optimized by using a thick copper multi-layer PCB. Thermal derating performance can be further enhanced by incorporating thermal circuitry in the layers of the PCB. And finally, advanced cooling simulation software, such as flow therm models, are available for standard power modules on the Flex Power Module website, for example, to provide accurate and fast thermal analysis. Now, let's take a look at and compare discrete solutions versus modules when considering material management logistics during production. Discrete power solutions have an inherently high number of SKUs to source and manage across the lifetime of each component on the bill of material. And this process must be replicated for each and every voltage rail. Modules, on the other hand, obviously reduce the number of SKUs, and SKUs are only needed for the module itself, along with some minimal complementary filtering. This leads to dramatically less effort needed for procurement and last time buy for each power rail on a motherboard. Testing during manufacturing is the next category we'll discuss. During the assembly of a motherboard, none of the numerous individual components making up a discrete power rail have been tested with other components in its bill of material. Also, it can be challenging to isolate and test this power solution from other circuitry on the motherboard. In contrast, the power module undergoes a large array of tests performed during its production. This adds peace of mind knowing that all the components of the module have already been confirmed to operate within its published specifications. Also, customization of a module is possible while being manufactured. For example, most of today's digital POL modules offer a wide range of output voltages. Let's assume a desired output voltage range for a given rail is known at the time the purchase order is placed for the power module. For example, an FPGA will operate from 0.8 to 0.9 volts. It's possible to tune the current monitoring accuracy around that voltage range during the assembly process of the power module, taking into account the variability of all the components. So the current monitoring accuracy at that specified voltage range can be further increased. So what happens when the inevitable occurs and there is a failure? With discrete solutions, it can be difficult to trace faults on the motherboard, and the entire board may need to be scrapped. However, a power module is easy to replace, and the failure analysis report is the responsibility of the power supply manufacturer. Also, many of today's modules include the ability to record data for events such as over-temperature fault, over-voltage fault, or over-current fault. After the fault has occurred, the user is able to view various registers at the time of the failure. Similar to a black box recording on commercial aircraft, this could be an invaluable troubleshooting tool in determining the root causes that led up to the failure. Also, manufacturing test data is logged and stored by the manufacturer for each module, as well as component traceability to further facilitate failure investigations. Now, the final category we're going to look at focuses on the impact that the two power design approaches can have on the customer's product launch date and continuation of product shipments. First, let's take a look at the discrete component solution. There can be an increased time to market due to long design cycles. And again, this is further evident with motherboards having dozens of voltage rails. Another item to consider is that a discrete solution does not offer second sourcing. The recent pandemic highlights the importance of having multiple sourcing channels. And modules, on the other hand, have a much shorter design cycle and complex sequencing and tracking requirements for a multitude of voltage rails can be accomplished with just a few mouse clicks when using tools such as the Flex Power Designer. The result can be a dramatically reduced time to market. Since there are so many standard module footprints available, second sourcing also becomes a viable option. So in summary, here's a list of power modules' advantages and disadvantages relative to discrete solutions. Once these other areas are taken into consideration, their combined weight in the decision-making process just might surpass that of primarily considering only the discrete BOM cost. Thank you very much for attending, everyone.